So this is a screencast to show the solution to an IB style question for math studies, and this question here about three-dimensional Pythagoras theorem. Okay, so the following diagram shows a box in the shape of a cube 6 centimeters in length. Okay, so all the edges are 6 centimeters in length from the definition in the question. What is the length from E to D? This triangle is going to help me answer that question. So I'm going to just label this triangle so you can see which bit of the 3D shape I've extracted. I'm going to label that point E, this point D, and this is going to be point H. So that is a right angle I can see, and we're looking at the base of the cube, so I know that that is 6 centimeters, and I know that that is 6 centimeters. So now, to work out the length ED, I'm using Pythagoras' theorem that says that the length ED squared will be equal to 6 squared plus 6 squared, which we'll do some quick simplifying there, is equal to 72. So ED will be equal to the square root of 72. I'll just rewrite that. ED is equal to the square root of 72. Now if I get my calculator, I can do that fairly quickly, and often I find a shortcut to square rooting is to raise to the power of the half. The square root button is there on your calculator, so if we do it that way this time, if you like, the square root of 72 is equal to 8.485 and so on. And as ever, I recommend that you write the whole of your calculator display down as an answer. ED equals 8.485281374, and then round it to 3 significant figures, so you end up with 8.49 as your answer to 3 significant figures. For the next part of the question, B, it's going to be helpful to have another triangle, so I'll just grab this one here, and bring that into picture, so we can extract another two-dimensional shape from this diagram. And I'll just label the points to show that, again, this is going to be point E. Now this is going to be point D. So I've just travelled across from E to D and then up to C. Okay, and again that's another right angled triangle. So CD for me, I know the length, it's 6 centimeters, it's one of the cube lengths, but ED is the one we've just worked out from the previous question, so it would be really important to make sure you use that number. Now again, to avoid rounding errors, I'm going to refer to that as the square root of 72. Although you're perfectly entitled to use this answer in the next step of the calculation, it's encouraged to avoid rounding as much as possible so that errors don't accumulate. So I now need to work out EC. So again, I'm going to be using Pythagoras' theorem and say that EC squared is equal to the square root of 72 squared plus 6 squared. Well, if I square the square root of 72, I end up with 72. Alright, plus 36, and I add those together, I've got 108. And so EC is the square root of 108. Again, calculator back here. We'll use another method for finding the square root now. 108 to the power of 0.5 does exactly the same thing, and that gives me my answer. Going to write down the calculator display, and it says 10.39230.485, which rounds to 10.4 to 3 significant figures. In both cases, I should make sure I include the units with my answers, and there we have the answers to this question.